But let's get into some of the probability we're going to be doing today, guys. See, now, Asanda, you've completely derailed me because now I'm in a good mood. I feel like we should all just go party. No, I'm kidding. Lerato, you're gonna do great. You're gonna do great. Let's just more Asanda energy. More Asanda energy. There we go. Everybody, some Asanda energy all around. Asanda, just I need you to positive vibes. MathsLive positive vibes. Give everybody your positive vibes because I think everybody's gonna do great. Well done, everyone. And Lerato, you're gonna do great. Okay, I have every faith in you. You'll do wonderful. All right, guys, let's actually get started on the lesson. Otherwise, we're not going to get anywhere. We're just going to have such a good vibes time, and we're not going to get far. All right, let's get on with today's lesson. Let's look at the question that we've been given over here. Now, Hulani, thank you so much. Hello, Hulani, has already told us, what do we notice about these two events that have been given on the screen? She says that they are mutually exclusive. They are mutually exclusive, and she's not wrong. But how do we know that they are mutually exclusive? How do we know this? What tells us this? Yes, Abu, lovely. Because there's no intersection. Exactly. So event A and event B can't happen at the same time because there's no overlap. All right. So let's start with calculating for the probability of A or B. Oh, Hulani, there is a union. There's no intersection. That's the one. Abu's got it spot on. Remember, the intersection is where they cross. The union would be both of them together. Okay, so there is a difference there. All right, so no intersection. But I'm glad we're using all the right words. So I don't think I'm going to be using and or anymore. I'm just going to use union and intersection and complement for this lesson, just to see if everybody's with me here. Okay, so we're going to remember the formula that we were learning about for or. Or means addition, right? So we're going to have the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Now, the thing is, we don't have an intersection B. So what does this tell us about this whole value? What is the probability of A intersection B? What would the probability of it be? Because I know the probability of A is 0.7, that's it. And the probability of B 0.1, that's it, short stuff. The probability of A intersection B should be 0. There's nothing there. So technically, we don't even have to calculate for this part. So when two events are mutually exclusive, that part doesn't exist. All right, so we can calculate for the probability of A union B. That's just going to be 0.7 plus 0.1, and that gives us 0.8. All right. And then it says here, explain why A and B are not complementary. And I want to use this particular question to just clarify something because I'm not 100% sure that I did it completely correct. Okay, so I want us to think about something. If we've got two events, A and B, okay, if I only have two events, A and B, if I want the complement of A, I know that the complement of A is 1 minus A. Thumbs up. Are we all okay with this idea? Or rather the probability of A complement. Are we all okay with this? Cool. Now, if I only have two events, the complement of A is just going to be B. Because if it's not A, it has to be B. Okay, same with the complement of B. I know that the complement of B is 1 minus B. But if I only have two events, then the complement of B should just be A. Thumbs up. Did that make sense? Well done, Abu. Okay, are we all okay with this idea? That if I have two events, for them to be complementary, not A must equal B, and not B must equal A. So let's look at this question B that I've got on the screen. It says, explain why A and B are not complementary. Well, let's do the math behind it, right? Let's go ahead and do the math. I know that the probability of a complement is equal to 1 minus 0.7, which is equal to 0.3. This is not equal to the probability of B. And I also know that the probability of B complement is equal to 1 minus the probability of B, which is 0.1, and that is 0.9, and that is not equal to the probability of A. And that is why they are not complementary. All right. Are we all cool here? Yes? Okay. Lovely stuff. We're going to move. We're going to move because today is the very last lesson and I want us to tie everything we've learned together. But we're going to first do a little bit of a recap. Let's do a little bit of a recap. Let's think about all the things that we've learned so far. So we've learned quite a lot, I'll tell you that. So first we learned about S, and S is a set. What is the set of S? Who remembers? The very last lesson on probability. Not guys, it's not time for holiday just yet. It's the last lesson on probability. Okay. Sorry, Didi Malone gift. I now realize that I may have been a bit hyperbolous in my speech. Right. I just meant the last lesson on probability. Okay. Do we remember what S is? S is the set of all, not sample size. This is the sample set. So it's the set of all possible outcomes, okay? I'll tell you what I mean by this, and I'll give an example quickly so that we're not confused about the two differences, right? The set of all possible outcomes. For instance, S could equal the faces of a die. So we would get the front face, which is a 1 on it, and then we would get the second face, which is a 2 on it, and then the third face, which is a 1, 2, 3. Okay, 1, 2, 3, 4. And then the fifth one, 1, 2, 3, 4, 5. And then the last one. At this point, guys, I'm just doing it because my OCD's kicked in. I'm sure we all understand the idea. That is the set. Okay. That is the sample set. Okay. Now, NS. NS is the sample size. This is the sample size, right? And we can tell from looking at the sample set that our sample size is going to be the number of elements in my set. The number of elements in my set. So my sample size must equal 6 because there are 6 things in my set. Thumbs up. Are we seeing the difference between sample set and sample size? Are we all okay there with the difference? Cool beans. Okay, sample set is everything that we can possibly get. A 1 or a 2 or a 3 or a 4 or a 5 or a 6. Sample sizes, how many of them do we have? Okay, the number of possible outcomes. So now let's talk about the event set. Okay, the event set will be the set of the possible outcomes of a single event. Possible outcomes of a single event. Like, let's say, for instance, we want our event set to be the prime numbers. So in this case, we would have a 2, we would have a 3, and we would have a 5. That's the event set. And then obviously, NE would be the event size. The event size. So NE would equal 3 because there are 3 sides that have prime numbers on them. Okay, and that's the difference between the set, the size, sample set, sample size. Okay, then we know if we want to calculate the probability of any event is going to equal to the event size over the sample size. Okay, that's something else that we learned. Okay, now let's go into some of the identities that we've learned. Right, we've learned that if we're calculating for the probability of A intersection B, who remembers what is the formula for A intersection B? The probability of intersection B. Do we multiply? Do we add? Do we divide? Do we subtract? What do we do in this particular formula? Probability of A intersection B, it's not subtract, I'll tell you that. I actually did give you guys the answer. It's not add and minus, Didi Malo. It's not add and then subtract. Intersection would be the multiplication rule. So the probability of A intersection is probability of A times the probability of B. And I knew we would need a recap today because we're going to use a lot of these. Okay, right? We're going to have to remember. Okay, then we have the probability of A union B, and that we're going to add, right? Remember, because A union B is the whole of A, the whole of B, and then because we've counted the intersection twice, we have to minus one of them. Do you remember that? It's called the addition rule. So the probability of A union B would be the probability of A plus the probability of B minus the probability of A intersection B. That's the equation that we're looking for that one. All right. Then the very last one is when we have to mutually, actually it's not the last one, I'm missing one. Mutually exclusive events, right? We know that for mutually exclusive events, that the probability of A intersection B needs to equal how much? How much should the probability of A's intersection with B equal if we're looking at two mutually exclusive events? I'm pretty sure somebody told us at the very beginning of the lesson when we were doing the example above. Guys, if the two things are mutually exclusive, do they have an intersection? No, they don't. So what is the probability of two things if they don't have an intersection? Or what is the probability of their intersection? It can't be 1, that's it, Didi Malo. It is 0. It's 0, okay, it's 0. So the probability of A intersection B when we're talking about mutually exclusive, that is 0. Which means that my calculation for the probability of the union is just going to be the probability of A union B is just going to equal the probability of A plus the probability of B, because they don't have an intersection, so this part falls away. All right, so that part will fall away. All right, then the last thing that we can chat about, last thing that we remember is the complement. So I know that the probability of A complement should be 1 minus the probability of A, and the probability of B complement should just be 1 minus the probability of B, and vice versa. The probability of A is just 1 minus, correct, Didi Malo, yes. Okay, the probability of B can be 1 minus probability not B. Okay, let me actually write that in. Or the probability of A could also mean 1 minus the probability of A complement, depending on what the question looks like. The probability of B could also equal 1 minus the probability of B complement. All right. Okay, I'm going to give everybody 15 seconds. Take a screenshot. Take a screenshot. You're going to need all this wonderful information as we go into the next set of work. All right. Okay, and give me a thumbs up when you're ready, guys. Oh, I'm so sorry, guys. My kids gave me the flu, and I'm not very happy with my school kids because I feel like they did it on purpose. The hugs from my grade 8 last week from my grade 8s last week. They felt very, 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 very deliberate. Oh, that's so true, Asanda. It is moving very fast. Oh, my word. Okay. Oh my gosh. Okay. Yes. Okay. Well, it was 29 where I am. So Abu clearly. It is. It is. Because they come here and they walk straight up to their desk, to your desk, and they're like, ma'am, can you help me? And now look at me. Look at what's happened in my life. Okay, all right, let's get into some of the work today. All right, today we're going to be talking about independence, and I don't know why on this earth I've done this again. Okay, all right. So when we talk about independence, we need to look at whether two events are independent or not independent. And the way we can see this on a Venn diagram is if we take the two probabilities, that probability and that probability. If I calculate for A and B, and it gives me that answer, because technically this is A and B. If it gives me this answer, then that means that events A and B are independent. And this is what I mean. I mean that the probability of A and B, or A union, I'm saying union, my goodness, my brain is fried. Okay, the probability of A intersection B must also equal the probability of A times the probability of B. Let's go see if this is true. Now, when I look at this drawing over here, this Venn diagram, I know by looking at it that the probability of A intersection B is equal to 0.34. Now, I need to go and actually do the calculation to determine whether it is actually independent or not. So I have to go, the probability of A intersection B is equal to the probability of A multiplied by the probability of B, which is equal to the probability of A would be 0.17 times the probability of B, which is 0.2. If I multiply these things together, I do in fact get the probability of 0.34. So because the calculation and the actual answer, because they match, then yes, these two are independent. The two events are independent. Thumbs up. Everybody okay? Is it not? Is it 0.034? Hey, guys, look at me lying to you. I'm so sorry. Okay, so clearly I didn't do the right things, guys. This question should have actually read like this. Hey guys, it's been a long day of flu. Please, no judgment. So this question should have looked like this. I'm so sorry. Okay, so this answer must have been 0.034 and this one should have been 0.034. I'm very sorry. I was testing you and you passed. Well done, guys. Well done. All right. Is everybody okay with what I've just done here, even though I know I did it wrong? Yes? Thumbs up. Are we all okay with this? Okay, so the only way that we can determine whether they are independent or not is if the intersection of A, or A times B, the probability of A times the probability of B, gives us the actual thing that we have in the intersection. Okay. All right, let's look at this question. I want you guys to tell me, are the two events A and B independent? Yes or no? Narisha just starts by saying yes. We need to do a little bit of calculation here, correct. Okay, so the only way we're going to get the mark is by actually doing the calculation. And Hulani and Tidimalo, you are spot on. It is not. He isn't. Okay, Narisha. Okay, let's do the calculation. We know that the probability of A intersection B has been given as 0.08. But now we need to do the actual calculation. The probability of A multiplied by the probability of B is equal to 0.8 times 0.12. Now, if I multiply these two things, I get 0.96. These two things are not the same, therefore not independent. Okay, does that make sense? Isuka, guys. Hey, yeah. It's been a long day, guys. I'm so sorry. 0,096. This is what I get for trying to do calculations in my head while a little buzzed because I've got a flu and I've got nasal congestion. This is not fair. Okay. But either way, guys, it's not independent. Oxalayo. Oxalayo, it's not independent. You understand? Okay. It was a test, Abu, and you passed. You all passed. Are we all okay? Everybody okay? Despite me, I'm not. I hope everybody else is. Okay, let's move on. Okay. All right, guys, let's look at the next question. Let's completely leave this. I hope you guys learned the lesson, the proper lesson here, that the answer should have been not independent. Okay, let's use formulae only. Now, you're only going to be able to use your formula here because we don't have a diagram. We don't have any of that. I would like you guys to answer these questions over here. We're going to call this number 1. Okay, I want you guys to read the information very, very carefully. Read the information carefully. Okay. And I'm going to give everybody 4 minutes because there are 4 questions and they're very easy to answer this. All right, take it away, guys. And I do know the answer to these questions, so I promise I will. Less than 1 minute, guys. All right, peeps, let's have a look at the answers. Let's start at the beginning. Now, I need us to be very careful about what we've been given here. The first part says if P of not A is 0,25, P of A or B is 0, 8, and the P of A and B is 0, 15. It starts by saying determine P of A. Now, I know that P of A complement is the same as 1 minus P of A. So if I'm calculating for the probability of A, I'm going to go 0, 0.25 is equal to 1 minus the probability of A. Okay, that means that the probability of A should be 0, 0.75. Right, that's A. Okay, let's go to B. The probability of B is going to be a little bit trickier in that we need all the other calculations in order to get there. Okay, now, if I'm looking for the probability of B, I don't have any information about the probability of anything else, but I have been told, the probability of anything else with just B. So I have been told that probability of A or B is 0, 0.8. So I can go the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So I can leverage this because I know what that part is. I know what that part is. I know what that part is. That will help me calculate for the probability of B. So the probability of A or B is 0, 0.8 is equal to the probability of A is 0.75 plus the probability of B minus 0, 0.15. Ooh. Guys, my apologies. I don't know what's going on here. Okay. So if we move things around, we should get that the probability of B is equal to 0, 0.2. Okay, correct me if I'm wrong, guys. Lovely. Thank you, Abu. That's the one I was looking for. Okay, because I know I've been missing zeros and I've been missing things. Please, guys, just check me quickly. All right, let's look at this last part over here. Now, for C, they're telling us that they want the probability of A and not B. So we know that the calculation for and is multiplication. So if we split this up, we're going to split this up into the probability of A multiplied by the probability of B complement, because they want to not B. All right, that's going to equal probability of A 0, 0.75 times the probability of not B. We know what B is. It's 0, 0.2. So we know that not B is going to be 1 minus 0, 0.2, which is equal to, my answer is valid. Thank you very much. 0, 0.75 times 0, 0.8 is equal to 0, 0.6. All right, 1 mark, 1 mark, 1 mark. Pop in the chat. How much did we get out of 3, guys? How did we do out of 3? 2, okay. 2 out of 3. Okay, Larato also says 2. Everyone else, how did we do, guys? I have a feeling Abu got 3. Okay. Hi, Bo, Abu. You're not supposed to be typing, you're supposed to be writing. Oh. I know, I'm like, how does that make any sense? I'm not understanding. Okay, it's fine. All right, okay. Oh, I see. Okay, that's fine. What's wrong with your right hand? It feels better. Okay. All right, guys, those of you who got 2 out of 3, do we understand what we didn't quite get right? Which one was it that was a little bit tricky? Which one did we not quite get? B, okay. Lerato, you know what? The last one. Okay. So it's just in the way we read it. Okay, Lani, so make sure that we're reading the question properly. Okay. So let's look at the next question. It's going to be very easy. It's going to be fast. So you've all got 2 minutes. 2 minutes to do this. Okay. Let's look at question 2. You've got 2 minutes. Go. All right, guys, time is up. Time is up. Let's have a look at these questions. This is such an easy question. I'm going to ask everybody. The question that we're looking at over here actually hinges on a particular statement. It hinges on the fact that they've given us the probability of A and the probability of B, where A and B are what? They are mutually exclusive events. What does that mean? What does that mean? They never intersect. Let's be more specific because we'd already looked at it. Do I need to scroll back up to remind us? Yes, no intersection. But remember, guys, we're dealing with the probability. What does this mean for the probability? Yes, that's it, Khulani and Tidimalo. That means the intersection, the probability of the intersection must equal 0. Now, just because we are able to calculate for the intersection does not mean that the intersection exists. Okay, which means you've given us a void answer. It's not a real answer. Okay, so let's start at the beginning. This is why I'm saying this question is very easy. At the beginning, it says the probability of A is 0.3, probability of B is 0.4, and A and B are mutually exclusive events. What is the probability of A and B? 0. We're off to a great start. The answer there should just be 0. Okay. Then we can take it from there. It's okay, Abu, it happens. We just need to read. It's all good. All right. So from there, we know that for B, we can calculate. So we're going to have the probability of A, or is union B, is equal to the probability of A plus the probability of B. Now it should say minus the probability of A and B, but we don't have to add that because we already know that the probability of A and B is 0. Right, so we're just going to use those two, which is equal to 0, 0.3 plus 0, 0.4. That is equal to 0, 0.7. All right. Well done, Hilani, that's it. Okay, next question says we want the probability of not A or B, but we already know what A or B is. We've just calculated what A or B is. Now they just want A or B complement. So we can just say the probability of A union B complement is just going to be 1 minus the thing that we calculated before. 1 minus 0, 0.7, which is 0, 0.3. All right. Thumbs up. Are we okay with how we did these questions? It's very important, guys. We must read and we must use the formula properly. Guys, it's very, very, very important that we remember what mutually exclusive events means for our probability. Okay. And Abu, like I always say, we make the mistake here and not in the test that we're going to write. We do it here. So that in the test, when they give us something like this, we're like, it caught me during the practice at MathsLive, but not here, not today, Satan. Not in the tests. Okay. All right, let's move to the next one. Okay, I want you guys to try this one. I'm going to give you guys 3 minutes, and then we're going to keep it moving after this. All right, this is question 3. Take it away, guys. Abu, are you struggling a bit? Okay, it's okay. Let's start with the reading of the question. Okay, because time technically is over. Okay, I'm gonna get into the question, guys. Thumbs up. Is it okay if I start answering the question? Yeah. Okay. All right, let's have a look at the question. Now, when we're reading here, it says A and B are mutually exclusive events. So we already know that there's no intersection. Agreed? There is no intersection. What does that tell us about the probability of A and B? That's it. Didimalo, good, good, Abu. Okay, the probability of A and B should be 0, right? Because they're mutually exclusive. Then they tell us that the probability of not A is 0.3. So if we know what the probability of not A is, can we then calculate for the probability of A? What is the probability of A, guys? Aha. Are we seeing it now? That's it. Abu. Lovely. We now know that the probability of A is 0.7. Right. Now, when we answer this question, determine the probability of B. We know that we have the probability of A or B. It's been given to us. So we say that probability of A or B is equal to the probability of A plus the probability of B. Normally, we would say minus the probability of A and B. But because we know that they're mutually exclusive, this part does not exist. That part is equal to 0. So we don't need to add it. We're just working with that. Now all we need to do is just sub in. I know that the probability of A or B is 0.8, which is equal to the probability of A, because we knew what not A is, would be 0.7 plus the probability of B. Therefore, the probability of B would have to equal how much? What is the probability of B equal to? That's it. Ah, we're getting it now. That's it, 0.1. All right. Then it says, explain why A and B are not complementary. Now remember, guys, if I have two events A and B, A complement should equal B, and B complement should equal A. But we also know that A complement can be calculated as 1 minus A, and B complement can be calculated as 1 minus B. So if we do the calculation, let's see if one is the complement of the other. Okay, I know A complement is going to be 1 minus, I don't even have to calculate A complement. I know what it is. It's 0.3. 0.3, but B is equal to 0.1 and not 0.3. This is not equal to the probability of B. Therefore, they're not complementary. And we could do the same with B. We could say B complement should be A, it should be 0.7, and it's not, because the probability of A, it's 0.1, 0.9, my apologies. So 1 minus, guys, it's been a long day, and this flu is not helping. B complement should be 0.9, thank you very much. 0.9, which is not equal to A, because A, the probability of A is actually 0.7. So those two are not mutually exclusive. Thumbs up. Are we okay with these two? Yes? Okay, lovely stuff. All right, let's finish up, peeps. Okay. Here's your next question. But in each of these questions, I want us to first draw a Venn diagram. We're going to use these to draw a Venn diagram, because for each of the questions that we're about to do, we're going to ask ourselves, are these events independent? Do we remember how we calculated for independence at the beginning? We must find the intersection, and if we take the probability of A and the probability of B, and they don't give us the intersection, then they are not independent. Okay, so I'll give you guys a bit of time to think this one through, and then we can calculate. Oh, shame. Okay, Abu. I'm sorry, guys. We're not going to be able to do dependent or independent for this particular question. It will come in the next one. Oh my gosh, my brain is shutting down. No, Abu, what you're going to do is you're going to study, and at exactly 10:30, you're going to switch off, you're going to go to bed. Whatever you learned is whatever you learned. Whatever you didn't learn is whatever you didn't learn. Because if you try and cram any more into your brain after 10:30, you're going to lose everything that you already know, to try and make space for things that are not necessary. Okay, so if you try anything further than 10:30, your brain is just going to be like, oh, here's some nice, lovely information that here's some nice information that that I don't need anymore because I'm being fed new information, and it's just going to kick out everything that you already know. Okay, so don't do that. All right, peeps, let's have a look at this question. Oh my goodness. Whew. Thank you. I was worried. I was like, oh, should I be offended? Okay, try the quizzes. Do the quizzes. The quizzes really do help. You can redo them as many times as you need. So go do the quizzes. Oh, wait, we don't have finance quizzes yet. Okay, yeah, fine. Go to Kevin Maths. That's fine. Thank you very much, Didi Malo. I appreciate that. Oh, thank you very much, guys. All right, peeps, let's look at these questions quickly before we run out of time. All right, so this question says here, the probability that a person drinks milk is 0,6. The probability of drinking water is 0,3. The probability of drinking neither is 0,2. Calculate the probability of drinking both milk and water. There it is. And so we're going to use what we've been given here, and we're going to calculate for the intersection. So I'm just going to write this in a way that will make sense to us. So we're going to go the probability of M, the P of M, that is milk, is equal to 0,6. The probability of W, which is water, is equal to 0,3, right? And the probability of them drinking neither, which is basically just the complement of the whole event, is 0,2. That already tells us that probability M and W, or the probability of M and W are not complementary. Okay, so we want the probability of water, milk and water, so we'll say the probability of M times the probability of W is equal to 0,6 times 0,3, which is equal to 0, please tell me I'm correct this time, 0.6 times 0.3 equals 0,18. Okay, I did it right this time, guys. I did. This time I did it correctly because I checked. I checked. Okay, 0,18. All right. Okay, now it says, what is the probability of drinking only one of the two drinks? So only one would mean I would drink either milk or water. Thumbs up. Is that making sense? Is the way that ma'am has explained what only one of the two means, does that make sense to you guys? Yes? If I have to drink only one, what are my two options? My options is either milk or water. So that makes it an or question, that is a union question. So we can say that the probability of milk or water is going to be the probability of milk plus the probability of water minus the probability of milk and water. Now I'm writing B because we are so used to writing B for everything. A and B for everything. There we go. All right, that's going to equal 0,6 plus 0,3 minus 0,18. All right, that's okay, Abu. Thank you for sticking here. Okay, minus 0,18, that should give us 0,72. 0,72. All right. Okay,